In the question number 36, the speed of sound in air at NTP is 330 meter per second. The percentage error in speed of sound as calculated from Newton's formula is nearly, and gamma is given 1.4. Okay, so you know the Newton formula is pressure to the density, and this is the value of suppose V1. And if I go for B2 according to the Laplace correction, because this is another one. So Laplace correction relation between this is root gamma times into V. V1 I mean to say, because we know this relation. So if I use this for the percentage, we'll write change between V2 upon V1 for percentage multiplied with 100. So we'll put the value of gamma times of V1 minus V1 divided by V1 into 100. V1 we will cancel out, and you know the value of gamma is 1.4. When you will place the value after calculation, we'll get 15%. So my option number 1 will be the right choice. Let's move on question number 37. In the problem number 37, two forks A and B sounded together produce 10 beats in 2 seconds, means beat frequency will be 10 by 2 means 5, because frequency of beat is given by beats per second. That's why I am doing this. The fork A is in unison with 25 centimeter length of sonometer wire, and B is in unison with 20 centimeter of length of the same wire. At same tension, the frequency of tuning forks are. So I know the formula 1 upon 2L T by mu. Tension and mu are constant, so I can write N inversely proportional to L, or N into L is equal to constant. So that is very good point. For A, for B, we'll write L2 upon L1 because inversely proportional to N. So L2 is 20, L1 is 25 as per the question. So 4 upon 5 you will get. So I can make a relation between, if I take cross multiplication, 5 times of Na and 4 times of Nb, and that will indicate Nb is greater than Na also. So now I am going to use the formula of beat frequency. So we'll write Nb minus Na, that is 5, as I discussed here. 5 you will take. So this is your equation number 2 and this is your equation number 1. If I place the value of Nb here, because you can write the value of Na in terms of Nb 4 upon 5 times. So when you will use equation 1 and 2 easily, यहाँ से Na का वैल्यू Nb के टर्म में, Nb का वैल्यू Na के टर्म में इस इक्वेशन में यूज करोगे, then on solving you will get Na 20 and Nb will be 25. So by this calculation you can easily find option number 2 will be the right choice. 2. We'll move question number 38. Question number 38. A set of 30 tuning forks is arranged in a series of decreasing frequencies. Two consecutive tuning forks produce 5 beats per second. If the frequency of first fork is twice of last tuning fork, I would like to repeat, frequency of first fork is twice of last tuning fork, then frequency of last tuning fork is. Okay. So in this type of question, I would like to suggest you will use F1 minus Fn, n minus 1 into Fv. You can memorize this. Now I am going to explain this. F1 minus Fn. Now n, we'll see, set 30 tuning fork. Okay, but question says if frequency of first fork is twice that of last tuning fork, then frequency of last tuning fork is, and two consecutive tuning fork produces 5 beats per second. It means n is n minus 1, n is 30 minus 1 into, okay, 5 beats per second, yes. 5. N means number of tuning forks. And the left hand side I will write last means F1 by 2 according to the problem, and that is 145. 29 into 5 you will get 145. So when you will calculate, you will get the value of F1 290 Hertz. So that will implies F1 by 2. This is our requirement. Will get 145 Hertz. So my option number 2 will be the right choice. We'll move question number 39. In the question number 39, a man is standing on a railway platform listening to whistle of engine that passes the man at constant speed without stopping. Okay. If engine passes the man at time t0, okay, then frequency of whistle as heard by man varies with time is given by. Okay. First I would like to write the formula. F0 V plus minus V0 V plus minus Vs. This is the formula. Now I am going to say something. When engine approaches man, then frequency is higher and constant. Clear? When engine passes man, then frequency here lowered but remain constant. कहना ये चाहता हूं कि जब इंजन मैन को अप्रोच करेगा तो फ्रीक्वेंसी हायर भी होगी और कांस्टेंट भी होगी, लेकिन जैसे ही इंजन उससे दूर जाएगा फ्रीक्वेंसी लोअर्ड और रिमेन कांस्टेंट भी. तो अगर इस टाइप से आप देखते हो तो ऑप्शन नंबर 2 में कांस्टेंट, डिक्रीज बट कांस्टेंट. सो मोस्ट एप्रोप्रिएट ग्राफ विल बी 2. So my option number 2 will be the right choice. We'll move question number 40. In the question number 40, a band playing music, frequency 1000 Hertz, moving towards a wall with a speed of 10 meter per second. Okay, means if this is a wall, this is suppose band, and motorcyclist is following the band with 5 meter per second. Frequency of reflected wave noted by motorist in Hertz. Okay. Speed of sound is given. So suppose this is the position of motorist. This one. Speed is 5 meter per second and speed of band is 10 meter per second. Right. The frequency of reflected wave noted by. Okay, reflected. Because as I discussed in the previous question, the formula for finding the apparent frequency F0, speed of sound plus minus observer plus minus source. Frequency of reflected sound. First I am going to calculate frequency of reflected sound. So we'll write F1 because 1000 is given and speed was 330 and band is moving with 10. Okay. So when I will calculate, we'll get 330 upon 320 into 1000. But when motorcyclist is moving towards wall, then I will use F2, F1 because this frequency I will use V plus V0 and V. So we'll get 1000 330 divided by 320 into 33530. So when I will calculate, we'll get 335 320 multiplied with 1000. So that is the final calculation. So I can say my option number 3rd will be the right choice. We'll move question number 41.